Welcome to springlib.
So in this question, we have a parallel plate capacitor with fixed charge positive Q and negative Q. Now, the separation of the plate is tripled. It goes from D to 3D. Part A asks, by what factor does the energy stored in the electric field changes? Delta E over, let's just say, E later over E initial. Part B is how much work must be done to increase the separation. And we know the area is A. So in order to solve this question, we already know that, well, maybe compared to EU might be a better number. So we already have the equation that in the chapter that tells us the amount of energy that is stored in a capacitor. And that is, one form of it is Q squared over 2C. And here, because it's the same charge, this is just C1 over C2. And we can rewrite it in terms of the determination of capacitor. And the area stays the same, and the distance becomes 3 times. So C2, the capacitance, decreases by a factor of 3. So the energy increases by a factor of 3. And then let's find the work. The work is U2 minus U1. So the work will be, let's simplify it because we know U2 equals 3 times U1. So this is just 2 times U1. So U1 is Q squared over 2C1. So 2 times that is Q squared over C1. And then the C1, that is the previous capacitance, is epsilon A over D. So this is the amount of work that is required to triple the separation.